Hello, my name is Vincenzo, and today I'll be showing you how to make an Arduino-based security system. So to start, some of the things you'll need for this build is an Arduino Uno. I'm using the Arduino Uno Model 3. You'll need a 4x4 matrix keypad. You'll need a small breadboard, a red and green LED, two 100 ohm resistors. We'll need a small servo with the half horn. We'll also need an 8 ohm speaker or a piezo buzzer, whatever you have. You'll need some jumper wires. You'll need 8 male-to-male jumper cables for the keypad. You'll need 2 male-to-female jumper wires for the speaker, and 3 male-to-female jumper wires for the servo. And some of the tools that you will need is a star screwdriver and wire cutters. So the first thing you're going to do is make sure you have a clean area to start. So I'm going to move everything to the side. So the first thing you're going to do is grab your Arduino Uno and your breadboard. First thing I'm going to do is grab my yellow jumper wire. It doesn't have to be yellow, it can be black or any color, and I connect it to the ground of the Arduino, and I connect it to the ground over here on the breadboard. Once you've done that, you can grab your red LED, plug the cathode, the negative, into the power rail, and the positive, the anode, into any row of the breadboard, and do the same for the green LED. Once that's complete, you're going to grab your 2 100 ohm resistors, and you're just going to place them in series with each anode of the LED. Right now, I'm not going to be trimming anything because I'm just testing it right now. This is my first prototype. Now with 2 other jumper cables, we're going to connect the red LED to A1 of the Arduino. Just tuck that all the way. And for the green, do the same, but connect it to A0. Once that step is complete, you're going to want to grab your 4x4 matrix keypad and your 8 male-to-male jumper cables. Add male-to-female, so I just added male headers on this side. So you're going to connect those to pins 2 to pin 8 of the Arduino Uno. Once that's done, you can just, from pins 8 to pins 2, connect it to the keypad like this. Once that's done, you're going to want to grab your servo and 3 of your jumper wires. So I'm going to be using a black, white, and gray one. Black and white I'll use for ground and power, and gray I'll use for the control pin. And I connect the white to 5 volts and ground obviously to ground. And the control pin of the Arduino I'm going to connect to pin 10. Once that's complete, you're going to want to grab your 8-ohm speaker. And right now I just have these 2 jumper wires I'm going to be using to connect it, doesn't matter which way. I'm going to connect one of them to ground and the other one to pin 11 of the Arduino. I'll just bring them over this way, and there's no polarity, so I can just connect it to either pin, doesn't matter. And for the hardware, that's pretty much it. The reason why I use the analog pins for the LEDs is because I only have pin 12 and 13 available left for the digital pins, and I may add another sensor, so I may need those pins, so I'm just using the analog to control them. On to the software. Hello everyone, this is Vincenzo, also Floppy Arduino, and today we're going to be doing the second part of the Arduino Security System. This is the software side. So the first thing you're going to want to do is open up a blank Arduino sketch. Once your sketch is open, I always like to start my code with okay then. My keyboard was a little frozen there. So I always like to start my programs with a multi-line comment with my name, date, and the project. I always like to start saving from the beginning so you don't lose any work. I'm just going to call this demo for security system. As you can see there, I already made a test, but I'm going to go step by step and show you how it's done. So the first thing you're going to want to do is import 3 libraries. So you're going to use the function hashtag include. And you're going to want to include the password.h library. I'm just going to copy and paste this 3 times. You're going to want to include keypad.h and servo.h. So what we're going to want to do after creating our 3 libraries, we're going to want to create 3 things. We're going to want to create a servo and 2 passwords. So we're going to create a servo. So we're going to call servo, and we'll name it lock, put your semicolon, and we'll just add a comment, create a servo. Then we're going to want to create our 2 passwords. So our first one we'll call password. We'll call it pass, and it's going to equal password. Open a bracket, open double quotes, and for now, I don't know, we'll just set it to something. We can always change it after, but for now we'll do 1593570. Create like a little X pattern on the keypad. We can always change it after, like I said, but we'll set that for now. Close your quote, close your bracket, add a semicolon, and this creates the main login password. And this is a function that we'll use later on. We're going to create an admin account, so we can see how many times the system was unlocked, incorrect, and do all that stuff. And eventually in the future I might add a function where we can change the main login password. So obviously we need a password to get in there, so we'll call password again. This time we'll call it admin, and it will equal to a password. And then just using the things on the keypad, I basically spelled out code AD for code admin, so I just set it to C0D3AD. So it kind of spells out like code AD for code admin. We can always change it after. So now, from this point, now we're going to want to start creating all our variables and all our pins and stuff. So I'm going to set up the keypad first. So I'll make a little section. I'll call it keypad setup. And the first things that we're going to want to define is the pins that the keypad is set to. So I'm going to call byte, then I call it row pins, and it is going to be an array. So we'll open and close a square bracket, and it's going to equal, open up a curly brace, and the pins that are going to be for the rows is going to be pins, it's going to be pins 9, 8, 7, and 6. We'll do the same thing for the columns. So I'll name these just call pins. And this will be set to 5, 4, 5, 4, 3, and 2. You can change these depending on which pins you're using on your Arduino, but this is what I used. So row pins, call pins. Now we're going to want to create a constant byte. I'll call it rows, and it's equal to 4 because we have 4 rows. So if we have 4 rows on our keypad, we'll create another constant byte. We'll call this one columns, so I'll just write calls, and also we have 4 columns, so we'll do that. For our call on keypad, save there. So the next thing we're going to want to do is create a key map. So we're going to create the characters, of the keypad. So we're going to create a character array. We'll just call it keys. So for the first value in the array, we're going to pass in rows, and for this we'll pass in columns. This is a 2D array. So equal, open up your curly brace. So now you're going to want to, in single quotes, spaced out by commas, you're going to type in each item on your keypad. So I want 3 of these and 1 without. So now you're just going to read your keypad left to right, top to bottom. So on my keypad, this is 1, 2, 3, and a capital letter A. Here is going to be 4, 5, 6, and B. This is going to be 7, 8, 9, C. And then this is star, 0, pound symbol, and D. So these are the characters on the keypad we're going to use. So the next thing after this, okay, your semicolon there. We're going to use a function called keypad. So we're going to create our actual keypad. So we're going to call keypad with a capital K, and we can use whatever we want. Just because it's a keypad, why not just call it keypad as well? And we're going to set that to a keypad, and we're going to pass in another function as a first thing called make key map. And this, using our keys, we're going to create basically our 4x4 matrix with all our row pins, our column pins, rows, calls, I think that's pretty much it for that. So basically what we've done here, we've created our keypad called Keypad, and we're creating the keypad, and we're gonna map the keys with the character array that we made here, using these pins for the rows and columns, and a number of rows and a number of columns. So for the keypad, that's pretty much it. So I'll just separate this section. You don't really have to, it's just easier to find where each thing is if you have to go troubleshooting. And then this is just going to be other pins and variables. So now we're going to want to create a few variables to store our pins. So we're going to create an integer. We'll call it red LED. This is going to be on pin A1. And this is going to be used for, this is going to be the red incorrect LED. So when the password's incorrect, it'll flash that. We'll do another one. This is going to be the green LED. This is going to be on A0. Green LED for correct. We're going to have a servo, which is going to be locking or unlocking your door, safe, whatever you want to use this for. So we'll just call it servo pin. And it's going to be on pin 10. No. Servo, whatever. We're going to have a little speaker, so I'll just name it speaker. And it's going to be on pin 11 of the Arduino. And the reason, I'm just going to mention this now, the reason why for the red and green LED, why I used the analog pins, just because I really wanted to adjust the brightness instead of having to use PWM or whatever, but I might want to add another sensor or something to this build, and since I've already used all except for 2 of my digital pins, I wanted to leave those empty in case I want to add another sensor. But if you don't want anything else, you can just easily use pins 12 and 13 for your LEDs and just use digital rate wherever you see analog rate. So after we created those, we're just going to create other variables. So these will be other variables for storing data. So we're going to have an integer called tries, and this will just be set to 3. So this is going to be used for amount of login attempts. We'll have 2 other integers called we'll call it times unlocked and incorrect. Set this to 0. These will be used to store amount of times system was logged into or pass incorrect. And I think that's basically all the variables we're going to need. So now we can go into our setup section of the program. The first thing we're going to want to do is start our serial monitor so we can receive text from the Arduino, data from the Arduino, and just for also debugging or whatever. So we're going to call serial.begin. This will start the serial monitor, and we'll just give it 9600 baud rate, which is just a standard. You can use 11500 or any other baud rate you want. Just this is 9600 is more than enough, and it's good enough for our uses. Like, you don't really have to go higher. It's not really sending information, it's just sending a few lines of text. So 9600 is fine. So this just starts the monitor. Now we'll set our pin types. We'll just say pin types. So we're going to call the function pin mode, which basically you pass in the pin that you want, and you pass whatever you want it to be So either input, output, there's also pull up, but we don't have to worry about that. So we're basically just going to be using output for this because the keypad feature already sets what the input and output pins for it, so we don't have to worry about this stuff. Just all of these variables here, our LEDs, our servo and speaker, that's what we have to set. So we'll start with our red LED. It's going to be an output. Just copy and paste this a few times. Then we can edit it. This will be our green LED. This will be our servo pin. This will be our speaker. Another thing we'll do is we'll attach our servo. So we're going to we named our servo lock, so we're going to write lock.attach. So this will attach the servo to a specific pin, and we want to attach it to our servo pin. So we're just going to type in servo pin here. This attaches the servo to the servo pin on digital 10. So next we are going to want to make sure the servo is in its locked position. So for me, I'd used 10, so we're going to do lock.write 10. Use servo to locked position. So this is setting servo. We'll just say this. The next section will be startup text. So here we're just going to output some basic text to the serial monitor. So we're going to call serial.print ln. So it's going to print a line of text to the monitor, and we're going to say use star to enter the password. Use pound to clear. We'll do another print line, so serial.print. We'll say enter password. And I think that's it for the setup section. We'll just save there so we don't lose any of our work. So next we're going to go into our loop section, and our loop section is very simple because it's literally 2 lines of code which just calls some of our other functions that we'll be making shortly. So for our loop section, all we're going to do is we're going to call our keypad that we made, keypad with lowercase k because that's what we named it, and we're going to get key. So what this does is the get key function, which is part of the keypad library, is gonna be constantly looping and trying to see which key is being pressed. So that's the one thing. And actually I forgot something in our setup section. This won't work because we need to have a event listener that will be looking for key presses. So we have to call one more feature in our setup. Is going to be keypad. So our keypad.add event listener, and we're going to create a function called keypad event. So right now, obviously, if we save and just to verify, we will get an error here because this function is not declared because we haven't made it yet. So we're going to do that in the next step in 1 minute. So then here we're just going to always make sure our servo is in the locked position again. So we're going to say lock.write 10 locked position, look for keypad presses. So our loop section, that's basically it. Now we have to do the 2 main functions, which is going to be our check password function, which will be comparing what we enter to the passwords, and we're going to have another function which is going to be our keypad event, which will be looking for the keys, getting the key press, and doing all that stuff. So we're going to create another method. I'm used to calling them methods because I used to code Java. I think they're called the same in C. Functions, methods, whatever you want to call them. So this one is going to be void keypad event, and we're going to pass in keypad event and e-key. So the keypad event is a feature in the keypad library, which is pretty self-explanatory. It's going to look for a keypad event, so an event from the keypad if a button is pressed or released or held. In this case, we're only using the pressed feature. We don't have to worry about any of the other ones because they're not really useful for our application. And then e-key is just a preset variable used for storing the key that's being pressed. Extra. Okay. So the first thing we're going to want to do in our thing is create a switch case. So basically, you could use an if statement, but this way is just better. So we're just going to use a switch case. So we're going to say switch. If I can spell correctly today. And in our switch, we're going to pass in keypad.get state. So this will basically run when a button is being pressed. So if it's true, then it will run this section. So our case is going to be pressed in caps like that with a colon, not a semicolon. I like to indent my line to just show that what's part of which section. So in our case, we're going to print out serial.print, and we'll just say tries left. So this would be used to tell the user when they press the key how many attempts they have left to log in. We'll serial.print our variable tries. And then we are going to serial.print line. No, just do a regular print. Enter. So from here, now to make it sound like kind of like a realistic alarm system or safe, we're going to use a function called tone, which is basically going to play a frequency with a duration to a piezo, a buzzer, whatever you have, speaker. So the things that you can take in for this function is the pin. So we're going to pass in speaker. Let's say we want the frequency of 900 hertz, and we'll just say a very small delay, 50 milliseconds for the duration. So this plays beep, tone, and speaker when key is pressed. Just save. And the next thing we're going to do here is now just do serial print line descent, so print ln, and we're going to print e key so the user knows what button is being pressed. So now switch, yeah. So after this switch, we're going to create another switch. It's going to be e key. So this will determine if special buttons like the pound or star are being pressed. So the first thing we want to do in here is create a case in single quotes. Our first case will be the star key, regular colon, not semicolon, indent. So if our star is pressed, which is our enter key, so this will be our enter password button. I don't know, you can label it whatever you want. It's our key to enter the password into the system. So we're going to call a function called check password, And right now we still have to create that, so this will just call our check password method function, whatever you want to call it. So after we call that, we'll just put a small delay in, 10 milliseconds, more than enough just so it has a little bit of time. Take a break. So the microcontroller is not always running, just has like a little second to take a breather, whatever. And then after this, we'll put our break statement. Break. Now we'll go back one tab. We're going to create another case. And single quote system is going to be our pound symbol. So if our pound symbol is pressed, we're going to want to reset our password. So set all passwords to clear. So we're going to use the function called reset, which is part of the password library. So we're going to call our variable, so let's say password.reset. That will reset our main login password to clear, and we'll clear our admin password. .reset. Reset. We'll just put another small delay. They're not necessary, just helps to have a few, even if it's a fraction of a second, just to try and get your program to run a little smoother instead of just bang 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 fast. It has some time. And then we'll put another break. Can't type today. And now we're going to create our default statement. So if none of these are true, so default so our default is just, it's going to use a function called append. So basically it will send whatever key is being pressed into the password library, which has its own functions and stuff built into it, and it will do all the comparing and math behind the scenes, so we don't have to worry about all that. So we're just going to do password called the pass.append, and we'll do the same for admin. There are other ways of doing this, I just have it send whatever key is being pressed to both passwords, and whichever one's true, it'll log into that. Well, login. It'll just run a certain code depending on which login it is. So if the main password login is correct, when you run the check password, it'll just do a basic unlock. If the admin password is correct, it'll go into the admin section and just print out the amount of times unlocked, whatever. Maybe in the future, part of the admin account will be probably like to set a new password, but I'm still working that out. So for now, it's good as is. So basically, I think for this function, we are done. Now let's create our last function, which, as seen here, is going to be our check password function. So this is the function that's actually going to be doing all the math, calculating which password is correct or whatever. So we're going to create a void, and we call the check password, and it does not need to take in anything, so you can just open and close a bracket, open your curly braces. And the first thing you're going to want to do in your password function, you're going to want to create an if statement. So this one will be if the regular login password is correct. Should comment this a little bit first before we move on to here. Sends the key press to the password library, whatever. You don't really have to, but whatever. So our first case, like as I just mentioned, is going to be if the regular password is correct. So we're going to call pass.evaluate. So basically, if the password evaluates to our pass, which is our regular login password. So if it's true, we're going to get it and do our little login sequence. So we're going to serial.print line password correct unlocked for, I don't know, let's say 10 seconds. Yeah, 10 seconds sounds right. That should be good enough. So it'll print that out to the monitor, and now we'll just put a small delay in again, 5 milliseconds, whatever. Now we're going to want to move our servo to the unlocked position, so we're going to call our lock.right. And in my case, I just made it move 90 degrees, but just my servo didn't like certain positions, so I set 10 to be the locked and 110 to be my unlocked position. So moves servo to unlocked position. Then after that, we're going to want to play like a little unlock tone to the speaker. So just create a little unlock tone melody. So what we're going to do here is we're going to make use of our tone feature again, our tone function. So we're going to say tone speaker, and we'll say 900 for maybe 100 milliseconds. We'll put a small delay. Maybe we'll do 150 here. I'll just copy and paste this 2 more times, and we'll just change this one. We'll do maybe, I don't know, let's do 100. We'll do 1100, and this one will do 1200. I think that sounds pretty good. Just I'll close this section up. It just looks nicer, like I said before. You don't have to do all this stuff. It just helps separate the code a little bit. So if there's any problems, it'll be easier to find which section is not working. Just look in your code and say, okay, unlock section melody is not working. Just look for this section, and you know that's most likely where your error is. I guess, as I just said, you don't have to, but I like to do it. So now we're gonna turn on our LEDs and whatever. So we're gonna analog right. We'll say our green LED, and we're gonna have it right now full brightness. So max in analog is gonna be 255. So turn green LED on max. Now we're gonna want our little 10-second delay, so we're gonna call it delay, and 10 seconds is 10,000 milliseconds. We'll just, oops, forgot semicolon. Delays 10 seconds. Don't worry about all these little delays. It's not really gonna affect it too much. It doesn't have to be perfect, just whatever. So after our 10 seconds, we're going to want to turn our LED off. Instead of 255, we'll put 0 here. Turn LED off. We're going to want to move our servo to the unlocked, so we're going to call lock.right 10, which is we are locked. Move to locked position. We'll reset our total amount of tries back to 3. Tries equal to 3. Because when the password's incorrect, which is what we're going to do, we're going to do the admin password, and then the incorrect case for if both passwords are incorrect, it'll get rid of 1 try, whatever, every time you get it wrong. So obviously if you get it correct, it's going to reset. So that's what this is. We're just going to reset the amount of times. We're going to want to call our times unlocked. Let's see, yep. So times unlocked. So we're going to want to increment that by 1. So we'll call tries unlocked plus plus. This just adds 1 to times system was unlocked. And now we're going to want to reset the password, so we'll just call clear / reset passwords. So we're going to call pass.reset, just like before, admin.reset. Now I'll just do one last print serial. We'll do a print line here. We'll say locked serial.print line. We'll just say enter password. And for our regular case, for our password, that's done. So next we're going to do, we're going to make an else condition, an else if condition. Else if, this time it's going to be admin.evaluate. This time if the admin password is correct, basically it's going to be almost the same, so we could copy and paste, but we'll just go through step by step just for whatever. So we'll just increment before we'll reset our tries and increment the times unlocked. So after this, we'll do a serial.print. We'll say admin account. We'll do another. Well, before we'll put this to the unlocked position. So we'll do our lock.write 110. You could use a variable for this, but it doesn't really matter. Instead of always typing 10 and 110, you could just put like make a variable for locked and unlocked position. Doesn't really matter, but moves to unlocked position. So then after here, I just thought it'd be cool to make like a little animation, so I'll just call loading thing. I don't really know, you can name it whatever you want. So I'm gonna serial.print checking. So here we're gonna make like a little animation to make it seem like it's loading into like an admin account. So now we're gonna make use of a for loop, which will repeat a certain amount of times based on a condition. So it's not like a while or do while loop. It's that either has to be true or something, whatever. This you just set the beginning value, the ending value, and how much it's incrementing or decrementing by. So we're gonna use for. We'll just create an integer. We'll call it int c. It'll start at 0. C. We'll say we'll loop until it's less than 8, and we'll say C++, which will just increment it by 1 each time. And then all we'll do is in here, we'll just print like a star, make it look like it's doing something. We'll just put like a half-second delay, so delay 500. We'll just space this out a little bit, just a little cleaner. Just a little bit of that stuff, just whatever. So after this, we'll just serial.print. We'll just use the /n, which will basically tell it to make a new line. Even though it's a line here, will just help space it out a little bit. Creates an empty line. Whatever. We'll just make it look nicer when it's coming out of the serial monitor. And now we're gonna print times full system was unlocked. So this is where the variables before times unlocked and what we're using the next one the incorrect, it'll just store how many times either the admin or regular account were logged into, or the passwords were incorrect. It's just a cool to have feature. It's not necessary, but we're in a serial print times unlocked. I'll put a little delay to wait a little bit in between the next one. We'll just do 2 seconds. Delay 2 seconds, and then after this, this system was unlocked. Passwords were not correct. So we'll basically do the same thing here, but instead this will be incorrect. Times password was not correct. Then after this, we can actually just, instead of 2000, we'll just do 4000, so that's 6 seconds. 9, 10. It kind of works out to be like a little bit longer, actually. I'm trying to think. This will be, that'll be 1 second, 2 seconds, 3 seconds, 4, 5, 6, 7, 8, 9, 10. Yeah, so this will pretty much work out, with this whole section, it'll pretty much work out to about, like before a period, like a 10-second unlock basically. So the total will be about 10 seconds. You don't have, it's not going to be perfect, but it's going to be good enough. And then, just like before, we'll reset our passwords. So I'm just going to copy and paste because I don't feel like retyping it. This will clear / reset. Passwords locked, enter passwords. We'll want to reset our tries to 3. So we'll just do tries equals 3, reset tries, and we're going to have one more condition, which is just going to be our else. So if both are incorrect, so we'll subtract 1 from try, so tries minus minus. So I'll take 1 away from total attempt, total tries. So then after this, we'll call a serial.print line. We'll say password incorrect, denied, try again. And then from here, we'll just put another small delay. 10 should be more than enough. Then from here, we're gonna make sure our thing is in the locked position. Oop, that's one thing I forgot here. So obviously we don't want it to stay in the unlocked position, so we'll put that to the locked position. Totally forgot about that. That wouldn't be good because then it would just stay unlocked. We don't want that. So we'll just make sure it's always in the locked position. So even though it's already there, we'll just rewrite it just to make sure it's in the locked position. And then we'll increment the variable incorrect, which we saw before up here for times incorrect. We'll just increment that by 1. Add 1 2 times incorrect. I'm just doing this quickly. Obviously, I'm going to edit this code later on because I want to add another feature in the admin section where you can be able to change the regular login password to something else. So right now I think we had it set to 159357. Maybe we can add a feature that you can, if you press a certain combination of keys in the admin account, it'll bring you to like a change password, and then you can like reset the password. But for now, we'll just do this. So after this, we'll do another for loop to play like a little unlock beeping tone. We'll just create another, we'll call it n. We'll set it to 0. Say n is less than 3. Sounds good enough. And plus plus, because it starts at 0, so this will make it beep 3 times. So now what we're going to do is tone, speaker. I think 400 would sound pretty good, and we'll do it for about half a second. And we'll do our analog, right? Our incorrect LED, so this will be the red LED. High. We'll delay should we do half a second? Yeah, half a second should be good. And then we'll do this. We'll just copy these 2 lines. Here instead of rain tone, we're going to use a function called no tone. You know, we don't really have to, because it has a preset duration before it shuts off. We'll just do it anyways. Instead of max brightness here, we'll put it to 0. So this will turn on the red LED. Turn off the red LED. A beep. Stop all sounds. So that will run 3 times. And then in our else, we're going to create another if statement. So if, this will be if our tries runs out, so if it equals 0, and note that we're not using 1 equals here because we're not setting something, we're using double equals, which is going to compare it to something. Oops. Need one more there to close it perfect. Okay. So if our tries is equal to 0, which means we've ran out of tries, what we're going to do is we're going to serial.print line, we'll say ran out of tries, locked for, we'll do 30 seconds. So basically similar to like a save for something you have at home. Once you have attempted, I think it's about usually 3 tries, it locks out the system for a preset amount of time. Usually it's 30 seconds or a minute before you can re-enter the system to try and log in again. So that's what we're going to do here. We're going to make a little lockout basically, so once you run out of the tries. So what we're going to do here, we'll just do another for loop. We'll just make another integer, temporary integer, we'll call it t. We'll start it at 30, or run until 3 is greater than 0. We'll say t minus minus, which will decrement the value t instead of adding one like before. It's gonna subtract 1 in this case, and we'll just do a we'll just put a little new line there just to make it look nicer here. So here we'll do a serial.print, we'll just say t. We'll analog right our red LED on max brightness. We'll delay half a second, and then we'll set this to off. Oops. We'll set that to off. Wait another second. That seems pretty good. So turn red lady on, off, delay half second. One thing we haven't done in a while is save, because we want to make sure we don't lose any of our work. Then after the 30 seconds is up, we'll reset our we'll just fix this formatting up a little bit so you can tell what's what. So once that for loop is over, we're going to reset our tries back to 3. Reset tries. We're almost done. We have a couple more lines. And I'll play re-enabled tone. So this will just play like a little 2 beeps to let you know that the system's been restarted, or like not unlocked, but like it's unlocked you from being able to not enter passwords, so now you can like re-enter passwords again. So let's do tone speaker. We'll do 900 again for 50. We'll delay this time 50. We'll make it very fast. And now we'll call serial.print. This time we'll print a line. We'll just make a new line. We'll say enter password, just like before. And we have one more line of code we have to add, which is our reset password. So we'll say pass.reset. Oops, forgot semicolon. We'll do our admin.reset. Reset passwords. And if we did this all correctly, hopefully we get no errors. We got an error for the append. Did we not create the admin? We did admin. That is weird. Let me just check that quickly. So it should be working. So our default. That's what I forgot. We have to actually append something into it. So we're gonna do E key, because we have to actually pass something into it, because it doesn't know what it is. We have to pass something in. Now hopefully that all works. Oop, forgot semicolon. Did I miss anything else? Semicolon, semicolon, semicolon. Oop, not upload. I don't have my Arduino connected right now. But hopefully, after this compiles, hopefully we have no errors. And yep. So it did compile correctly. It's just there's no Arduino. So that's basically it. The software section is done. Now all you have to do is hook up your Arduino. Make sure everything's plugged in correctly, as seen in the last video, the hardware video. Upload it, open your serial monitor, and give it a shot. See you soon.